Hello, my name is Pedro Mendoza. I'm a solutions architect with Semtech, and today I will be demonstrating how to build an end-to-end solution using LoRa Edge technology and a set of AWS service and features in order to do asset tracking and geofence. Let me start by sharing my screen so you can see the high-level architecture of what we are going to be building today. So as you can see, this high-level architecture shows the main components of the solution. Everything starts with a LoRa Edge-based tracker. Today, we'll be using a Semtech reference design tracker, but I want to highlight that now we have a mature ecosystem of device manufacturers that actually have production-grade devices aimed for specific use cases, such as industrial asset tracking, animal tracking, personal tracking in the form of badging, as well as general purpose trackers. We will dive a bit deeper in a second. So in addition to a LoRa Edge device, we've been showcasing the recently announced integration between EveryNet and AWS in order to enable AWS customers to use the EveryNet public network to connect LoRaWAN devices to AWS. And we'll be also demonstrating the benefits of using IoT core device location and its seamless integration with the AWS IoT core for LoRaWAN, the managed LNS coming from AWS, as well as the integration between the IoT core Pulse engine with multiple destinations, including time stream, as well as Amazon Location Service. So let's start with the tracker. LoRa Edge is a technology developed by Semtech a couple of years ago that basically redefines the way a device location is computed. Traditionally, what is called on-chip GNSS will do the location computation on the device. This is a non-trivial computational operation that requires a non-neglectable amount of energy. When you have a large fleet of devices that operates on battery, and those devices are deployed in remote locations, extending the battery lifetime of your devices, as a consequence, extending the time that you are required to replace batteries, or even the device is basically doing any service, to 2 or 3 times the original expectation can be a significant cost-saving factor, right? That's basically what LoRa Edge does. LoRa Edge will reduce the amount of energy required on the device, and as a consequence, extend the battery life by only doing the minimum amount of operations on the device. It will just scan the sky to obtain the raw data coming from the space vehicles, or will just scan the accessible Wi-Fi access point when it comes to indoor location, and then we'll grab that raw information, we'll send it to the cloud, typically using LoRa and LoRaWAN, and then the actual latitude and longitude will be computed on the cloud by a solver. Obviously, on the cloud, you are no longer constrained by, let's say, power consumption, because you don't need to take into account the cost of a battery replacement on the cloud. So this is basically what the LoRa Edge chip does. Again, 3 main components: a GNSS scanner that will help you to do outdoor geolocation. You can scan either GPS or Beidou constellation. A Wi-Fi scanner in order to do indoor geolocation. It will scan the nearby Wi-Fi access point and will send the MAC address and signal strength to the cloud. And the third component is a best-in-class LoRa transceiver. As I mentioned, even if we are going to be using a Semtech reference design today, now we have at least 10 manufacturers that has been successfully tested and qualified their devices to properly work with AWS IoT core device protection. That basically means that you are starting a new project using the LoRa Edge technology. Now you have let's say, you can trust that those devices has been successfully qualified. We have devices that range from, let's say, animal tracking in the case of ASICSEN, to industrial asset tracking in the case of Truvani or Pecteli, right? But also you can do, for example, personal tracking by using a smart badge. We have devices coming from Seed. We have devices coming from Tectelic as well, and also we have devices coming from Mimic in this category. And then we have, let's say, more general purpose trackers. In this case, coming from Moco, coming from Osaka, coming from Rowan, and coming from Semtech. Again, if you have any question about the specific features of each devices, you can simply navigate to the AWS Partner Solution Finder, formerly known as the AWS Device Catalog, and you will see a new category here for AWS IoT Core Device Location. Simply select it, and then you can follow the links for each of these products. So going back to our high-level architecture, the next step, once you have your tracker successfully, let's say, configured, is making this information to be transmitted over the cloud, right? For that purpose, as I mentioned, we'll be using the EveryNet roaming agreement with AWS. And as you can see, as I'm doing the demo in Madrid, we are pretty well served by EveryNet in the urban area, right? So as I explained before, I can completely skip the need to deploy my own private network, right? I can save all the costs coming from buying, deploying, connecting, powering my LoRa WAN gateways, and instead I can use the already existing EveryNet infrastructure. Then we'll have the data ingestion in IoT Core for LoRa WAN. We can, with a single configuration step, translate this raw data into latitude and longitude, and then we can use it downstream, as I mentioned, for both visualization as well as notification purpose. Let me quickly show you my Grafana dashboard, right? As you can see, it's quite simple. I'm basically just using a base map, and then I'm using a geofence, in this case, an hexagon that is basically has been drawn around my home. And you can see that I already have a location, right? So this is a Wi-Fi location. If you hover over the point, you can see the latitude and longitude, the timestamp, and so on. This morning, I went out for a walk. So if I extend my, let's say, time window to the last 3 hours, in addition to a bunch of points nearby my home, you will be able to see as well some points in a nearby park, right? If we zoom in there, you will see that in addition to a Wi-Fi location, I have also obtained a couple of GNSS locations. Again, if I drill down on one of these points, in addition to the latitude and longitude, you will be able to see as well the accuracy that has been observed while computing the location. You can see, in this case, it was a 20 meter, which is pretty okay accuracy for most of the use cases, despite there is a kind of cloudy day in Madrid, right? Generally speaking, from Semtech, we expect that the accuracy for GNSS scanner can get as good as, let's say, 10 meters, right? But again, it really depends on the sky view conditions. So this is, let's say, what happened this morning. We can confirm as well that as part of this transition outside the geofence and then back into the geofence, the corresponding events were triggered. To do that, I would just check my CloudWatch log, right? You may recall in our high-level architecture that we are sending data to TimeStream for visualization using Grafana, but we are also sending data to Amazon Location Service. In this case, we're using an event bridge rule to send data to an SNS topic that is connected to an SMS notification, but also we're sending it to CloudWatch, right? So I should have received the SMS on my phone, but also we have received the corresponding logs in CloudWatch. So if I go to CloudWatch and I filter it to the last 3 hours, you should be able to see how at 12:43 there was an exit event connecting this tracker, which is the def EUI for my LoRa Edge tracker, and this geofence, which is basically that hexagon drawn around my. This basically says that, let's say, the tracker has breached the geofence, and that's why you have an exit event, right? You can as well get the specific position where the tracker was observed. And then something like 25 minutes later, right, 10 minutes or 9 minutes after 1 p.m., we can confirm that there was a corresponding enter event. This is basically when I return back home, And you can see as well, obviously, the specific timestamp. Please note that these are UTC versus this is local time. And the same device, the same geofence, right? And these are the coordinates where the tracker was observed to have entered the geofence. Okay, I think that basically covers the high-level demonstration I want to do today. But I would like to actually show you how you can, let's say, let me go a bit further down the timeline. So if I, for example, show you the last 7 days, right, where I've been doing some walks, you can see that actually I've been able to get some locations in between as well, right? And obviously that really depends on the position of my tracker at any given time, and even some additional locations open, right? Obviously, this is influenced by the coverage area of every net, right? That, as I showed you before, right? It's pretty good in the Madrid city center. I want to mention as well that, well, obviously, the ideal situation will be that you can rely solely on every net coverage, right? One of the benefits of the integration between AWS and EveryNet is that you can actually build hybrid networks. What this means is that you can use the EveryNet public network whenever it's available, but then you can combine it as well with your own gateways, with your own private network, right? And then the devices will be able to easily roam between your own private network using your own gateways and EveryNet gateways whenever available, right? This is, again, a very interesting topology that might be useful for certain conditions. So in order to, let's say, conclude the demonstration, I would like to very quickly show you how to onboard a new device, how easy it is, right? I will use another reference tracker. So this is my second reference tracker. I will just first provision it on the AWS LNS. So first thing I need to define is the specific activation mechanism that I will be using. Next, I will need to provide the dev EUI. So let me just make sure I got it right. I think that was the, okay, yeah. Okay, so this is my dev EUI 652E. This is the app key for the device, right? This is basically what is going to be used to encrypt the communication between the device and the network, right? I also need to provide the join EUI, and let me provide a friendly name here. I will use this one, 652E, which is the last 4 digits in the dev EUI. And that's basically all I need, right? From the device. The next thing I need to do is associate it with a profile, both a device profile as well as a service profile. I have already created those profiles, but they're really very simple to define. What is important as well here is that in order to enable this device to use the EveryNet network, let's say act in what is called in LoRa 1 roaming mode, I need to define a service profile with a couple of attributes configured to allow roaming, right? You can go to the AWS EveryNet integration configuration if you want to know more, right? But it's extremely simple, just 2 attributes that needs to be configured. And then the last element in my device provisioning is the destination, that basically translates into where I want to send the data coming from the device, right? I want to mention that this is, let's say, general LoRa 1 data, is not location-specific data, because all this configuration so far is generic to any LoRa 1 device. My destination, in this case, let's say the raw data destination, is just going to be publishing that to an encrypted topic. When I click next, I will now access the location-specific part of the configuration. And as I mentioned before, enabling the location computation on the cloud for this device should be as easy as toggling this configuration setting on, right? So I'm saying here that this device is, let's say, location aware, and as a consequence, the LNS will pay special attention to the data flowing through certain ports, and then when it's received data from the device through these ports, will automatically invoke the solver so you can get, like, say, the latitude and longitude without really writing a single line of code. And then the last configuration point here is what you want to do, in this case, with the location-specific information, with the latitude and longitude. This is where we are doing a bit more of, let's say, extra work. That's where we are going to be sending the data to TimeStream, to Amazon Location Service, and so on. And that should be it, right? So now we have provisioned our device. Next, I will be powering it on, right? So, okay. So I'm basically applying a magnet to my Semtech tracker. Now you can see it's a PLE carry mode. So I can use a companion mobile app to disable the airplane mode. Obviously, this is the way the Semtech reference strike works. Other devices has different ways to, let's say, physically activate it, right? Okay, so it should be now activated, right? So within few minutes, it should get, let's say, connected to the EveryNet network, right? And it should have start scanning both GNSS space vehicle as well as Wi-Fi access point. Most likely because I'm sitting indoor, it will not be able to get a clear sky view, but it should be able to scan some Wi-Fi access points and be able to successfully position it based on that information, right? So let's select it here. We can keep an eye on it. So you can see we have not yet received any uplink. We can complement this monitoring using the MQTT test client. As I mentioned, I have two destinations, one for the raw data, one for the location data, and both destinations are basically republishing the messages into MQTT topics, right? So I can easily use the MQTT test client in the AWS IoT console and monitor those MQTT topics, right? So I'll start by monitoring the uplink. Okay, test uplink topic. This is the raw data topic, and I will add a second monitor to the test location topic. This is where I will be publishing the location messages, right? So, okay, so far we have no data flow yet. It's probably still going through the join procedure. I will just check it a bit so I can force geolocation scanning as soon as possible, right? Let's keep an eye on the device as well. So while we wait for the device to successfully join the network and start sending location role information, we can dive a bit deeper into how the actual integration between the rules engine and TimeStream and Amazon Location Service is configured. To do that, I will go to the IoT Core rules engine, and here you will see that we have basically two rules. The raw data rule, which as mentioned is pretty simple. We're just republishing on an MQTT topic, right? So I will not really go there. But we have a second rule, which is the location rule, where we are basically republishing just for, let's say, monitoring purposes, but we're also sending to TimeStream, right, and to Amazon Location Service. The SQL expression here is extremely simple, right? We are not really doing any transformation or filtering there. And then the actions for TimeStream basically is built on extracting 4 different dimensions, right? So the device ID, as you can see, I'm reducing the same location and the same destination, the same rule for my complete fleet of devices. So it's really very, let's say, scalable from the configuration perspective. But then I need to be able to discriminate between the different devices that uses the same rule. That's what the device dimension is being used for. And I'm extracting it using substitution template from one of the attributes in the payload, right? And then I'm doing something similar for the latitude and longitude, right? Again, I'm using the different functions in the IoT Core SQL language. And finally, I'm also able to extract the accuracy of that location, right? So this is all you need to do to send data from IoT core rules engine into time stream. And then very similar, I'm doing that for the integration with Amazon Location Service, right? In this case, in addition to the dev ID and the latitude and longitude, what I'm doing, I'm obviously writing the timestamp, and also I'm selecting what is the logical tracker in Amazon Location Service that I will associate to my physical tracker, right? Let's, before we dive a bit deeper in the Amazon Location Service configuration, let's see if we have some activity here, right? So let me go back to my device to confirm that it has finally joined. Okay. Okay, so I can see that it has already received some uplinks that basically prove that it managed to connect using the EveryNet network, and now it has a valid session against the AWS IoT Core Floor 1. If we dive a bit deeper into the topics, right, you can see, right, some messages on the raw data topic, right? So this is basically data that we cannot really make sense, right? Unless we have some lambda, the codes and so on, right? I can tell you from the port number that this is Wi-Fi data, right? But apparently this is not from our new device, but from our old device, right? I can tell you from the dev UI, right? But now you can see that also our new device, the one ending in 652E, is also sending data on port 195, which I know is the Wi-Fi location, right? Again, keep in mind that we are now observing the raw data topic, right? So what device location will do is actually translate this encoded payload into a latitude and longitude, but without forcing me to write a single line of code. Then we can see the complementary topic, the topic where device location will actually publish the already solved position, and we can see how this is my first device, right? But I should have data for my second device here as well. And here we can see the latitude and longitude, right? I want to highlight as well that this is a recent extension to the, let's say, integration between EveryNet and AWS, that you can see as well now some metadata in the uplink messages, right? Including information about the specific gateways that has been observed in the uplink message from the device into the elements, right? But the most important thing here, again, is that you are able to get the latitude and longitude without writing a single line. So now that we have the location, actually, I should be able to, in the console for my new device, see the location on the map, right? This is, let's say, included in the console, right? It's taking some time. And we should be able as well, while we wait for this to finally render, we should be able to quickly check how Amazon Location Service is configured. Okay, it's taking some time. Looks like now the IoT console finally managed to render the position here, right? And you can see actually it's, has been found to be pretty close to my home. Let me see if we can get Amazon Location Service here, just to, again, at a very high level, see what is the configuration of the tracker and the geofence there, right? So, as mentioned, I have a single logical tracker that is being used to map all my physical trackers. I'm able to do that by basically using this device ID attribute, right, with the tracker. The tracker definition is pretty simple. All you need to do is basically, configure how you want to filter the position. If you want to make it, which is basically how you want to deduplicate positions that will be very similar, either time-wise or location-wise, right? There are several ways to do it. And then the second important attribute is whether or not you want to link your tracker to a geofence, which is basically whether you want to define what would be the allowed region where that tracker should be expected to reside. And then in our case, this is important because it will enable us to build this exit enter logic using the integration between Amazon Location Service and event reach in this case, right? So this is our geofence. I can click here. Unfortunately, Amazon Location Service console do not allow you to visualize the geofence, but you can trust me. This is the hexagon that I showed before here in GoFundMe, right? So let me just go back to 5 minutes, right? So if I zoom in, now I will expect that, one of these, at least one of these Wi-Fi locations. Okay, actually you see, so these two locations are from the same device, which is our old device, but this location is from our new device. You see, it's the one ending in 652E, right? So that basically proves that the end-to-end solution is working properly. I just provision my device, I configure it to use the right destinations, and then the existing, let's say, wiring did the rest, right? And then you have the position for free, right? And that's basically what I want to showcase, right? So just to complete the explanation in Amazon Location Service, this is my geofence. And then if I go to event reach, I should have a rule that basically first define what is the filtering criteria, what is the configuration that I want to react upon, right? And what I want to do, or what are the targets for that right? So let me quickly go there. So this is the rule, Amazon Location Monitor. If you see here the pattern for the event, which basically says what are the conditions that should be met, explain that I'm interested in this type of event, right? Give me just 1 second. This is the type of event that I'm interested in, which is basically both the exit as well as the enter event. And this is the specific geofence that I want to monitor, right? If I then move to the target, you will see how you can send it to multiple of destinations. In our case, we are sending it to an SMS topic that is then wired to an SMS being sent to my phone. And also we are sending it to the CloudWatch log group that we inspected, right? So again, this is, let's say, a demonstration of how you can build an end-to-end solution without a single line of code by combining a LoRa edge-based tracker, right? And you can select from all the different manufacturers that are now qualified to properly work with device location, and a combination of multiple services and features within the AWS ecosystem, including the recently announced agreement between Evernet and AWS to allow AWS customers to use the Evernet network for connecting LoRa devices. I hope this helps to, let's say, understand how this technology works. And please reach out to either AWS or Semtech team if you have any questions on how to build a similar solution. Thank you very much.